So what we're looking at here is a calculator question from paper 2 of the 2019 Higher. This is question 12 in that paper, and it focuses on logarithmic axes and plotting on these. Now the question tells us that two variables, x and y, are connected by the equation y equals ab to the power of x. Then shows us the graph of log to the base 4 of y against x in this straight line shown here with a couple of points marked on, and we have to find the values of a and b. Now first thing to note for this kind of question is that a and b are going to be constants within the context. So we have to treat them as being independent of x. X is the variable that we're going to be working with on the right hand side of the equation. A and b are the constants. We have to find the values of those. Now a question like this, what we have to do is introduce logs so that we can match up with this axis and the axis at the bottom. So if I introduce logs and I say, right, I'm going to take this equation here and I'm going to take log to the base 4 of both sides, I'd have log to the base 4 of y equals log to the base 4 of a, b, x. So what I've done is I've taken the equation and I've actually put it in terms of what I've got in my y-axis here anyway. Now I'm going to do a bit of jiggery pokery and move this right hand side about using my rules of logarithms. So what I'm going to do is split it to begin with, and I'll have log to the base 4 of a plus log to the base 4 of b to the power of x, and then I'm going to bring the x down in front, and I'm going to be able to say that my overall equation of the line is log to the base 4 of y equals x times log to the base 4 of b plus log to the base 4 of a. So now I've got this written in terms of the relationship between x and log to the base 4 of y are two variables. And you'll notice that when it's plotted, it's plotting x against this log to the base 4 of y. So each of these coordinates here essentially is in the format of representing an x and a log to the base 4 of y. So if I were to use these in this, wherever I've got a log to the base 4 of y, I would substitute the y part of the coordinate, and wherever I've got an x, I'd substitute the x part of the coordinate. So if I take this point here, my y-intercept, and I were to substitute it into this one here, what I'd end up getting is that negative 1 is equal, well this would be 0 times log to the base 4 of b, which is 0. So I'd get negative 1 is equal to log to the base 4 of a. If I then took this second point up here and substituted it in the same, what I'd end up getting is that 8 is equal to 3 log to the base 4 of b. I've then got plus log to the base 4 of a, but this first part here has shown me that log to the base 4 of a is negative 1. So I could put that in and make it minus 1. So if I then rearrange this bit here, I get 3 log to the base 4 of b equals 9. So log to the base 4 of b is equal to 3. So now I have something for log to the base 4 of a and log to the base 4 of b. What I'm able to do is take each of these and figure out what a and b are. Because I could say that since log to the base 4 of a is equal to negative 1, a is then equal to 4 to the power of negative 1. So a is equal to a quarter. Similarly with this one here, log to the base 4 of b is equal to 3, b is equal to 4 cubed, so b is equal to 64. So there you go, I've found the a and the b is required in the question itself. So following it through, this is how I'd approach a question like this. I'd try and get it in terms of the axes and the way it is. So in this case, a logarithmic in the y, and just a standard x in the x one. That's what you're going to find if it's of this format here, the y equals ab to the x. If you end up with something that is of a format y equals ax to the b, what you're going to do is take logs of both sides, and you'll end up with something that's a log y equals some number times a log of x, then plus a constant there as well. So slightly different, but what you'll find is what is the equivalent of your x and your log y axis here will be a log y axis and a log x axis in this sort of scenario here. But the general steps don't change. Equating it up, substituting in points, all follow the same routine. It's just making sure we get the right format and the right way to do it every time that works. But in this case, and in this scenario, we end up with these two solutions here, that A is a quarter and B is 64. Question like this, worth 5 marks. Following this method here, get 1 mark for this first step, taking logs and introducing them to both sides. Second mark is for getting to this point here and getting that log to the base 4 of y is equal to x times log to the base 4 of b plus log to the base 4 of a. If you kept the log to the base 4 of a first and had log to the base 4 of a plus x log to the base 4 of b, you'd still get the marks. That's fine. All right, the order doesn't matter when it's written like that. As long as you look at signs and make sure they're okay, it doesn't matter at that stage. We then get 1 mark for getting -1 is log to the base 4 of a. We then get our second mark for getting that log to the base 4 of b is 3. And then our fifth and final mark comes from getting the values of a and b from those two relationships there, where we know the log to the base 4 of a and b and what they are, and using our rules of logarithms to solve. Log axis questions tend to follow this sort of format here. Learn the steps, learn the routine, and you'll come up against no major issues with this, unless your algebra and you're working with logs and your rules of logarithms need a wee bit of a polishing up. Go and do that if you need to do it.